right, so this is part 3. All right, so in this video, we are going to do an example where we're able to both construct a confidence interval estimate for a population proportion using that one prop z int that I mentioned at the end of the last video. We're actually going to put some numbers in there, and then also how to interpret a confidence interval. So what do those numbers actually mean, and how do we want to interpret them? All right, so here is the information that we're going to use for this example. There are several parts, but it all is based on this information here. So in the parent-teen cell phone survey conducted by Princeton Survey Research Associates International, all that's just kind of extra stuff, 800 randomly sampled 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving. Of the 800 teenagers surveyed, 272 indicated that they text while driving. Now, this is one of those places where you've got a lot of words, and you've got to figure out which words are meaningful and which numbers are meaningful and what is just kind of there for context. Context is important. It's great to have an idea of what you're trying to figure out, but at the same time, like, some of this is just kind of extraneous data or information that we're being given that won't affect our numbers that we're putting into the calculator and what we're trying to interpret. They will come in handy when we actually do the interpretation, though. So first of all, we have some numbers here that aren't going to mean anything. 16 and 17, those are just the ages. That's our population. We do have our sample size, and we have our number of individuals that meet a certain characteristic. So we have the two values that we need to get started. And sure enough, our first question, I kind of shortened our information here so that we had the most pertinent information, although I did leave out one part, a random sample of 800 16 to 17-year-olds. So we want to find the best point estimate for the proportion of 16 to 17-year-olds living in the United States who have ever used their cell phone to text while driving. Remember, the best point estimate for a proportion is always going to be p hat. And p hat is x over n. We just saw that in a previous video. So it's just how, what's our sample proportion? Well, 272 out of 800. And it's perfectly fine to leave that as a fraction, but if we want to get it as a decimal, of course, just divide it out on the calculator. And this actually ends up being really nice. It is 0.34 or 34%. Now, because of the word proportion, I am going to use 0.34 as my actual answer. That stays in consistent with the problem that I'm working. All right, and part B says, can we use the one prop z int? So we just talked about this previously. We do have to meet some conditions in order to use the normal curve. Remember, that's what that z stands for, z for the z-score, and z-scores are our standardized normal curve. So we need to make sure that we can use that, and to do so, we just need to multiply out our sample size. So remember, n was 800. I can't believe I left that off of each of these, but there we go. So I'm going to say 800 times, and I just found p hat in part A, so I'm going to use that 0.34, and then 1 minus 0.34, and that needs to be greater than or equal to 10. So I'm going to put that in my calculator. So 800 times 0.34 times 0.66. Of course, that's, again, if I'm thinking about putting this into my calculator, I can just say 1 minus 0.34 if I want, or I think of it as counting out change. $1 minus the 34 cents that I owe on something, I'm going to get 66 cents back in change. And that gives me well above 10. I actually get 179.52, which is definitely larger than 10. And then I just need to double check, is my sample size, is that less than or equal to 5% of our overall population of all 16 to 17-year-olds living in the United States. So that's my population. My population is all 16 to 17-year-olds living in the United States. So do I feel like that 800 is a small enough sample? And yes, I really do. I don't feel like that's getting close to more than 5% of the population. All right, so now that we know we can use our one prop z int, that's what we need to do. We need to obtain a 95% confidence interval for the proportion of 16 to 17-year-olds who text while driving, and then we're going to interpret it. So first of all, we're going to obtain that confidence interval, and then once we've got it, we'll talk about how to interpret what those numbers mean. All right, so here we are. Like I said, I've done stat over to tests. I'm going to go down to one prop z int, and I'm going to put in the values that I've been given. So my x value that I was given was 272, and then out of course, the total of 800 total 16 to 17-year-olds. My confidence level is just going to stay 0.95, so I don't need to make any changes there. I can go down to calculate, and that's going to give me my confidence interval. So this is what I'm looking for. So I've got 0.30717 and 0.37283. So that is my confidence interval. There's my p-hat. We just calculated that, right? We found that 272 divided by 800 gave us 0.34. So that's nice that that's given to us. And then n equals 800. That's just reminding us what our sample size was. All right, so if I want to interpret this, I need to start with how confident I am. So we did a 95% confidence interval, so we are 95% confident. Now, what am I confident about? Well, the problem that we were dealing with this entire time was that we have these students, 16 to 17-year-olds, living in the United States, who text while driving, who use their cell phone to text while driving. So we are 95% confident. I'm going to go back to what I just had in part C. I'm just going to repeat that. So the proportion of 16 to 17-year-olds who text while driving. So we are 95% confident that the proportion of 16 to 17-year-olds, who text while driving I can't write. There we go. Is between, and I might round to 3 decimal places. Just go with whatever the homework tells you to, as always. It will tell you what it wants you to round to. I'm going to say 0.307 and 0.373, because that 8 will make that 2 round up to a 3. Now, This did say proportion, so I kept it as decimals. In our next example, we'll see that we start out with percentages. We want to keep it in percentages, and so we'll have to make sure we're paying attention. What does the problem ask for? Does it ask for percents, or does it ask for proportions?